Welcome to the General Math for HiSET program at NIAC. I'm your instructor, Jordan Monahan, and today we're going to be looking at number lines. Number lines show the arrangement of the different classifications of numbers. If you watched any of the videos in the previous assignment as a result of Welcome to the General Math for HiSET class at NIAC. I'm your instructor, Jordan Monahan, and for some of you, this is the first video you're watching. For others, you have watched a series of videos after taking that pre-assessment. And so today we'll be looking at number lines. Number lines show the arrangement of different classifications of numbers. If you watched any of those revision videos, you know that we talked about natural numbers, whole numbers, integers, rational numbers, and irrational numbers. But where do they really fall on the number line? If we look at natural numbers, we put these as any whole number except for 0. And if we looked at whole numbers are all of the natural numbers plus 0. So really the only thing we're changing here on this number line is we're adding in 0. Integers are all of the natural numbers, all of the whole numbers, and all of the negative whole numbers. -1, -2, -3, -4, -5. And the arrows at the end of this number line tell us that they go on forever and ever and ever, and they don't seem to end. Integers, or after integers, we have rational numbers. Rational numbers include natural numbers, whole numbers, and integers. And the new one here is going to be fractions and decimals. So we could have a half here. We could have -2.5 here. We could have -4.75. We could have 4.999 there. And then we have irrational numbers. Irrational numbers are interesting because they are not a part of the group before them. So it would be wrong to add those. These are completely separate. So what I'm going to do is I'm going to draw a line here and turn it into a box. Those numbers all belong together. Irrational is outside of that. But together, these make up the real numbers. So all of these in here are real numbers. So where are irrational numbers on the number line? These are going to be decimals that never end, like 4.999 ends. 4.75 ends. 1/3 is a fraction, but it goes on forever, but it repeats. 0.33333333333 forever and ever and ever. But irrational numbers don't do that. Pi has an equivalent of 3.1415, and it goes on. none of these numbers repeat. You might see some numbers back to back, but there is no pattern that continues to repeat. Another one that you might see is the square root of 3, or if I can fit this in here, the negative square root of 8. And we could continue to add various numbers from irrational and rational numbers all over this number line. What's really cool about the number line is that we're able to move left or right and move the starting point wherever we want. Like in this case, we started with 1. But we don't have to do that. 0 does not have to be a part of our number line if we don't want it to be. And we can zoom in or out. If we wanted to zoom out, maybe we pick negative 100 and negative 10. Notice how 0 isn't a part of this. 0 is somewhere over here. And our scale is different. We're using the exact same number line. They're the exact same size, same number of tick marks, but different scales. But we could also zoom in. And that's what I want to show down here. Maybe this is 7.8 and 7.9. Now our tick marks represent something different. 7.81, 7.82, 7.83, all the way to 7.9. So there are a few different types of problems that you can expect to see on your HiSET and CASAS tests. Dealing with number lines. The first one is estimating where values go. So it might tell you which of the following number lines shows the accurate placement for 3/4. And it could give you something like this. Okay. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 marks. So we know that this would be 9/10. Here's 7/10. And the reason I'm talking about tenths is because I know that 3/4 has a decimal equivalent of 0.75. 7/10 has the decimal of 0.7, which helps me locate on this particular number line the most accurate point, which is 3/4. Now, if those tick marks weren't there, I have to take a different approach. If it just said 0 to 1, what my goal would be is to mentally break this into 3 equally spaced parts as closely as I can and know that this would be, 4 equally spaced parts. And that would be the third line. 3/4, 2/4, 1/4. So if you make mistakes, it's no big deal. Erase, make your adjustment, and keep moving forward like I just demonstrated there. I didn't do that on purpose. For some reason, my brain flipped the 3 lines with 3 spaces. The next different type of problem that you could see is one that says place the following on a number line. It could give you a range of values that are rational numbers. It could even give you some irrational ones. But since we haven't talked much about irrational numbers and how we find their decimal equivalents, unless you've watched those review videos, I didn't want to throw them at you quite yet. The big thing here is it's easiest to compare numbers when they're all decimals. And now we just have to figure out what scale we want to use. I would suggest going with 0 to 2, with 1 being right in the middle. That would put 1/2 somewhere in here. This would be 0.8. 1/5 would be here. Here is 1.3, and 1.9 would be there. Understanding number lines will also help you if it asks you to order numbers from smallest to largest. Remember, smallest to largest. Another type of example it could give you, or another type of question it could give you, is give you a scale and have 4 or 5 different places marked. And then say which one of these accurately represents negative 0.25. In this case, the closest one to that would probably be B. I don't know exactly my scale on this one. I just put random marks on there. But number lines aren't always horizontal, especially in real life. There are some examples that would probably be really familiar to you, but you probably can't think of them right off the top of your head. They seem like pretty mundane, everyday things. One of them, if we spin this number line sideways, is elevation. So at 0 feet, we call this sea level. Mountains are typically thousands of feet above sea level. And trenches in the ocean can be thousands of feet below sea level. Now, above sea level and below sea level, those are really acting just like your negative and positive integer signs. So if you stumble across a question dealing with elevation and you need to calculate the difference between them, just keep in mind that if it's below sea level, it's like a negative integer or a negative rational number. Another example from real life has to do with thermometers. So if you've ever been sick, or if you've ever been in science class where you have to measure temperature, this is probably pretty familiar to you. Now there's different scales. We have degrees Fahrenheit. That's how we measure all of our temperatures here in the US for the most part, where 0 degrees Fahrenheit is not where ice freezes. That is 32 degrees Fahrenheit, right? Ice forms, water freezes. Water boils at 100 degrees Fahrenheit, which is the same in Celsius, except in Celsius, it's 0 degrees where ice forms. So if you ever see a thermometer outside, pay attention to that, and you can get another example of a vertical number line. There are a few more examples, but I would like to keep these videos short and sweet.